Hello, everybody. Mr. Mercier here. I'm just going to do a quick review of pretty much the same exact thing that you did last class with Mr. Crowther's videos. Um, so, sinusoidal graphs, okay, it's a fancy word for the sine and the cosine waves. They have a lot of real-world applications, which we'll be getting into next week. But we're doing a lot of the same skills that you've already done in previous classes. What you spent a lot of time in Algebra 2 was working on parent functions. Okay, and we did a bunch of things to these parent functions where we vertically stretched or shrunk something, right? So you had some sort of function f of x. It might have been, y equals x squared. A parabola might have been a cubic or a quartic or something like that. But different things that you can do to it. The number up front, is going to either vertically shrink or stretch it. Okay, and just remember it's a shrink if it's a fraction in between -1 and 1. And what else you could do? You could attach something to the b, and that would be a horizontal shrink or stretch. Okay, and it's the exact opposite here, where if this is a fraction, then it's going to horizontally stretch it. Okay, also we can move this thing right or left with the h, and we can move it up or down with the k. Right, Algebra 2 probably looked like this with some of your parent functions. Pre-calculus 1 from last semester, it looked like this, where we were doing things where we're just taking this thing and we're like moving it to the right 2, down 2, that type of thing. So the only thing that's changed now, instead of f of x, instead of being like a parabola or something, it's just going to be this wave, like y equals sine x and y equals cosine x. And you can do the same exact things that you did to it before, where I can vertically stretch it, I can horizontally stretch it, I can move it to the right or left, or I can move it up or down. Now, where these graphs come from, now what you think about when you're looking at these graphs, the x coordinate is degrees. So if I was talking about my sine, and this y is going to be the ratio of the opposite divided by the hypotenuse. So if I look at my unit circle off to the right here, okay, remember it's x comma y, or cosine comma sine. Okay, so where the sine starts. So the sine starts at 0 degrees. And if I look over here, the y coordinate at 0 is 1. Okay, now if I go over to 90 degrees, if I go to 90 degrees, the y coordinate is 1. Right there. Okay, and it takes on all of these values. So at 30 degrees or pi 6, it takes on the value of a half. Okay, and so on. Now cosine starts at a different spot, because at 0 degrees, so this would be your degrees or radians. And over here, this y-axis is the ratio of a over h, right? And you have all these coterminal angles, so this wave keeps on going on forever and ever and has the same value. So if I look at cosine, starts at 0 comma 1. So that's why cosine starts here, and the sine starts at 0, right? And then slowly, if I go to like 90 degrees, I'm back down to 0 right there. All right, now how these things look like on the graph. So if I look at right here, this 3 is going to horizontally shrink it by a scale factor of 3. So normally it takes exactly 2 pi, or if we go back to our thing, it takes exactly 1 full time around the circle to get back, or 360 degrees to get back to the original spot. Okay, so on this one, if I look at the blue graph, that's normal sine, but that 3 is going to shrink it horizontally. So it's going to be, instead of in 2 pi, it's going to be 2 pi divided by 3 is going to be my period. will be my period. Okay, now, in general, your period is always going to equal 2 pi over b. And b is the thing that's right in front, so that 3 is going to be our b. Now, also, you can vertically stretch or shrink your sines and cosines. Okay, so like this is going to change the amplitude of it. So it's going to be, make it 3 times as big, as tall, right? That doesn't necessarily affect the x. It doesn't affect it horizontally at all. It's only vertically. Okay, also, they have these things called phase shifts, which is just basically means move it right or left. So if I look at the purple or pink, okay, that is the normal sine graph, okay? And it does a full period in 2 pi or 360 degrees. Now, the only thing that's different here is the blue one. Now I'm going to shift that to the left 90 degrees or pi half, right? So everything gets moved. Everything gets moved 90 degrees that way, every single point. Okay, also, you can move these things up and down. Right, so this is every point gets moved up too. All right, now an example of types of problems you have or you had last time too was coming up with equations of lines. Okay, so for this one, now there's an infinite number of answers for these problems because you could make this a cosine wave, you could say it's a sine wave, because basically they're the same things, they're just kind of shifted over a little bit. So if I was coming up with an equation for this, okay, now let's just do cosine. Okay, cosine starts at the top. So I can either do it there or I could do it there. So if I started right there, and let's do cosine. Y is going to equal. First thing, let's see if this thing's been stretched out at all. Okay, so we know cosine's usually in between 1 and 1, so we have to figure out how tall this wave is. I'm going to draw a line right down the midline right there. Okay, sometimes it's called the axis of the wave, sometimes it's called the midline. It's just going to be the line in the middle. So if I look at this thing, this wave is going to be 3 units tall. So I'm going to put a 3 right there. Now let's figure out what our period is. So that's how long I'm going from like top to top or bottom to bottom. How long it takes to. So in between there and there is pi. So the period is always equal to 2 pi over b. We got 2 pi over b, and we say that this equals pi. So we're going to have to do some cross multiplying to really solve this thing for b. Okay, so multiply both sides by b, and then divide by pi, and I'm going to get b is equal to 2. I'm going to put a 2 right there. Now, this doesn't shift right or left at all, so I don't need to worry about putting anything right there. But this whole thing does. This used to be where the x-axis is, but it went down 1. So I'm going to go minus 1. Would be one of my equations that I could do. Okay, now there's other equations also. There's an infinite number of them. I could have started right here and then did like x minus pi for that. But let's say I wanted to do a sine equation for this. Okay, my sine equation would start right here. Okay, so it would start right here. Okay, and going up. Now it doesn't start right here because it's going down, right? Sine starts at the origin and goes up. So my equation for this line would be y equals, I'm going to have the same exact amplitude. It's still 3 times big. The period is still the same. Oops. So I'm going to have 2. Now this thing gets shifted to the right. Okay, so in between 90 and pi is going to be 3 pi fourths. and then I'm going to move my graph down -1. So that would also be a correct answer for that. Okay, and there's a ton of different correct answers that you could do for this. So hope this helped out a little bit. Try the 2 worksheets.